When you write the prime factorization of a number, you're writing the number as a product of its prime factors. Now, there's only one unique prime factorization for every integer greater than 1. So it doesn't matter the method that you use, you will get the same prime factorization if done correctly. There are two methods we'll discuss. We'll discuss using a factor tree and using the ladder method. In this video, we'll only focus on the factor tree. Now, a prime number has exactly two factors, and those two factors are 1 and the number itself. If it's a composite number, that means the number has more than two factors. So in example number 1, we're going to look at the number 32. We want to break this down to write this number as a product of its prime factors. So first off, I would look for, is the number even? Because if it's even, we know it's divisible by 2. 32 is even, and so it's divisible by 2. So what we're going to do here is make branches. And on these branches, we're going to pick any factor pair, any pair of numbers that will multiply together to get 32. Well, I'm going to pick 2 times what? 2 times what is 32? Well, that would be 16. Now, once you have a prime factor on your branch, it is done and you circle it. Okay, so 2 is prime, I circle it, I am not going to make additional branches. 16 though is composite, so I can break it down further. So again, I pick any factor pair that would give me 16. Well, again, 16 is even, so I can pick 2 and 8. Right? 2 times 8 is 16. I see 2 is prime, I circle it, and I don't make additional branches. 8 is composite, so I can keep going. I can make an additional branch. Let's say 2 times 4. That would give me 8. I see a 2. That's prime. I circle it. Last step here, 4 is composite, so I'm going to break it down into 2 times 2. Circle the prime numbers. So as you can see now, all the numbers on the end of the branches are prime. So 32 is the same as these numbers circled multiplied together. So that would be 2 times 2 times 2 times 2 times 2. And we have already learned that if you're multiplying a base repeatedly, we can write this using exponents. So this would be the same as 2, the base being repeatedly multiplied, 1, 2, 3, 4, 5 times. So 2 to the 5th power. So 32 is the same as 2 to the 5th power. This is the prime factorization of 32. Now, let's say that I had 32 and I picked a different factor pair. Instead of 2 times 16, what if I picked 4 times 8? Well, that's okay when you're using a factor tree. You can pick any factor pair. If I make additional branches on 4 to get 2 times 2, circle the prime numbers. And if I make additional branches on 8, I know that 8 is the same as 2 times 4, circle the prime number. And I break 4 down into 2 times 2. So in the end, I will get the same answer. I still have 2 times 2 times 2 times 2 times 2, which is 2 to the 5th. Okay, example number 2. Let's write the prime factorization of 33. 33. Okay, I know that 33 isn't divisible by 2 because it's odd, but it is divisible by 3, right? Because if I take the sum of the digits, if I add 3 plus 3, I get 6, and I know 6 is divisible by 3, so therefore this whole number, this 33, is also divisible by 3. So 3 times what would give me 33? Well, that would be 11. Now from here, I can't make any more additional branches because 3 is prime and 11 is prime. And so that is simply the prime factorization. 33, the prime factorization of 33 is 3 times 11. Now technically there are exponents of 1 here, right? 3 to the first times 11 to the first. But remember, if the exponent is 1, we don't really need to write it. It's just understood to be there. So this is the prime factorization of 33. Example number 3. Let's take the prime factorization of 34. I know 34 is even, so I can break this into 2 times something. Well, let's say I don't know what 2 times something equal 34 is. Well, I can do the inverse of multiplication, which is division, right? I can do 34 divided by 2, which would give me 17. I can double check this. 2 times 17, that would give me 34. Well, I know 2 is prime. Is 17 composite? Can I break this down any further? No, I can't. right? 17 is also prime. So just like we saw up here, this is it. 34 written as a product of its primes is simply 2 times 17. That is the prime factorization. I want you to try these two on your own. Okay, we'll call this example number 4. Write the prime factorization of 35. And then example number 5, do this one on your own also. Write the prime factorization of 36. Okay, so example 4 and example 5, write the prime factorization of 35 and 36. Do those on your own.